Okay, grade 8, this is your final review for your test, which is on Tuesday. You have a 4-day weekend, so hopefully you're using this on a Monday evening, getting yourself ready for your test tomorrow morning. These questions are pretty good review questions, so pay attention to how you do them because your test questions are going to be pretty similar. So the first practice question says a large Tim's coffee, 560 milliliters for $2.20 is a better deal than a small coffee, which is 286 milliliters for $1.65. So in order for us to compare these coffees, we have to look at them in unit rates. So we can check for a unit rate. Usually it's cost per volume. So we're going to put our milliliters in the bottom and our money up top. So for the large, it's going to be $2.20 for 560 mils. Now, as we said before, if you look for the cost for 1 milliliter of this coffee, what you're going to end up having is something that's less than a penny. So what we're going to do is we're going to find out what it is for a decaliter or 100 milliliters, which is a unit rate. So in order to find that, you can either divide by 560 and then multiply by 100, or you can simply divide by 5.6 to get that 100 right off the bat. And if I take my calculator and go, where's my calculator? Right here. $2.20 divided by 5.6, that tells me it's roughly 39.2 cents or 39.2 cents per 100 milliliters. So if I bought a large coffee, which came in 560, I'm really paying about 39 cents for every 100 milliliters of that coffee. A small coffee, on the other hand, is $1.65 for 286 milliliters. Now this one might seem more difficult to get to the 100, so I'm going to show you how to do it using the unit rate. So I'm going to make it equal to the cost per 1 milliliter and then the cost for 100 milliliters. Now just to be sure, you could divide it by 2.86 and 2.86 and that'll get you 100. But if you don't know that, I'm just going to show you how to do it without having to go do that part. Okay, so if I was to take this and divide by 286 and divide by 286 and take my calculator and say what's $1.65 divided between 286 milliliters, that would tell me that each milliliter is less than a penny. It's actually a little bit more than half a cent. So what I want to do is keep 5 decimal places because what I'm going to end up doing after that is multiplying that 1 milliliter by 100. And then when I multiply by 100, I move my decimal 2 places over. So it's going to be 57.6 cents. 57.6 cents, 7.6 cents per 100 milliliters. So for this one, you can clearly see that yes, the large is a better deal, and it's significantly a better deal. So the answer, therefore, is true. It's a better deal. The second true false says a car traveling 3.2 kilometers in 3 minutes down Granville Street, which is a speed limit of 40 kilometers an hour, is speeding. Is this true or false? So what we really need to do is figure out how many kilometers it was going in the hour. So my kilometer is going to be up top, and my time is going to be in the bottom. So the first rate, it says it goes 3.2 kilometers in 3 minutes. So in order for us to see how long that's going to be in kilometers per hour, I have to know how many minutes there are in an hour. And most of us know that there are 1 hour equals 60 minutes. So if I think about this bottom term as being 60 minutes, 3 minutes multiplied by 20 will give me 60 minutes or 1 hour. And if I multiply my first term by 20 as well, I will maintain proportionality. And 3.2 times 20 is 64, I think, but I'll just double check. So 3.2, oh, it's not that actually, times 20 is 64. So therefore, it is traveling 64 kilometers per hour and is speeding. So therefore, it is true again. It is speeding. Our third question says Sally made $43.40 for babysitting for 3.5 hours. Now, 3.5 hours means 3.5 hours, or if you want to think of it a different way, 3 hours and 30 minutes. She would make $99.20 if she worked 8 hours. So let's just double check to see what she makes as a unit rate. So if I say she made $43.40 for 3.5 hours, and then I want to see how much is she making for 1 hour, I could set that up as a unit rate, and I would know I would have to divide my second term by 3.5, and my first term by 3.5. And $43, move this over a little bit, and 40 cents divided by 3.5 would tell me that she's making $12.40 per hour. Now it then says she would make $99.20 if she worked 8 hours. Well, let's just double check that. If she worked 8 hours, I would take that hourly rate and I would multiply each by 8. And then I take my calculator and go $12.40 multiplied by the 8 hours she worked is 99.2. And therefore, if I put my zero there because it's money in this, then it's true because she is making $99.20 for 8 hours. And that would be the type of work you'd have to show to prove that it's true. Okay? Your fourth question says there are 6 oranges and 10 apples. That should say apples. The ratio of oranges to apples is 6 to 10, and therefore 60% are apples. Well, the problem with this question is that this is a part of our ratio, and this is a part of our ratio, and this, as we remember, is called a part-to-part ratio. 6 oranges to 10 apples. And the problem with 6 to 10 is it's not a part to whole, which is the one we can use percentages of. Because technically, if we were to draw that, there would be 16 pieces of fruit. There would be 6 apples, or 6 oranges and 10 apples. And 10 out of the 16 pieces of fruit are apples, and therefore 10 divided by 16, if we were to change that to a decimal, is 0.625, which is really 62.5%, not 60%. So the trick here was not to think of the part-to-part ratio as percentages, right? You have to have part to whole. So the answer for this one, therefore, is false. It's 62.5%. Question 5 is our first question that's not true, false. It says there are 3 spaceships, 6 moons, and 12 stars on a child's wall. What is the ratio in lowest terms of stars to spaceships? Stars to spaceships. So there's our stars right there. There's our spaceships right there. So if I was making it, stars has to be my first term of my ratio, and spaceships has to be my second. You can't switch them just because 3 is first here and 12 is here. You have to keep it in the order that the ratio describes. And if I'm to reduce it, I can think of it just like I would if I was reducing a fraction. I could divide by a common factor. In this case, both share 3. So the first term would be 4 and the second term would be 1. I could also do it here just the same way I did over here and then write it as 4 to 1. So therefore the ratio, that means for every 4 stars that are on this child's wall, one of them would be a spaceship with it. Right? So there's 12 stars, so therefore there's 3 spaceships. The second part says what percent of the objects are spaceships. So in this one you have to use that whole part to whole ratio against the part to whole ratio, which is what we use to make percentages. So spaceships as the part, there are 3 spaceships as a part. And as a whole, you're going to have to actually do a little bit of math. You're going to go 3, 9, 9 plus 12 is 21. So there are 3 spaceships to 21 total shapes on that child's wall. So if I was to write that as a part to whole ratio as a fraction, it would look like this. And if I was to reduce to the lowest terms, I could. I don't have to, but I could. It would be 1 to 7. And so really what we're looking for is what is 1/7 as a percentage. So we take 1 divided by 7. It gives us this big massive decimal, 0.142857, 142,857, etc. But we're really looking for percentages, so we just need to have the hundredths. So we have approximately 14 hundredths, which therefore is approximately, because we didn't use this as our percentage, approximately 14%. So about 14% of the shapes on that child's wall are spaceships is the answer we're looking for. Question 6 says the SIS A girls basketball team had 9 wins and 3 losses this season. What is their total win to loss to win ratio? Well, there's a tricky one. So in the review question it says loss to win, not win to loss. So the first thing you have to do is look for the losses. There are 3 losses, so that has to be your first term. And then the wins, there's 9. So your win to loss ratio is 3 to 9, but in lowest terms, we could reduce this to lowest terms, would be 1 to 3. So one lot for every loss they had 3 wins this season. What is their winning percentage? So for that one, you're going to have to do a part to whole again. So win to total games. And again, that number is actually not here. We have to do a little bit of math to figure that out. So they had 9 wins on the season, and they played 9 plus 3 is 12 total games. So therefore, they won 9 games out of 12, which if I take my calculator to figure out the percentage, 9 divided by 12 should be 75%. So therefore they won 75% of their games this season. So what is it as a ratio? That would be it as a ratio, and as a percentage, since it's a part to whole, the percentage would be 75%. Question 7 says, determine the unit rate for questions 7 through 10 and show all your work. It says it's $4.20 for 6 muffins. So you determine a unit rate. So what we want to go is per either dollar or per muffin. Now obviously, since it's set up this way, we're looking for the cost per muffin. So cost per muffin. So it's $4.20 for 6 muffins. Now to break that into a unit rate, we want our second term to be 1, which means I will divide both the first term of my ratio by 6 and the second term of my ratio by 6. And $4.20 divided by 6 is 70 cents. So therefore, you want to rewrite this again. So if this was a test question, you would go, therefore, the unit rate is 70 cents per muffin. All right? Per muffin, per 1 muffin, but we don't need to say per 1 muffin. We can just say per muffin. Question 8, it says 285 kilometers in 2.5 hours. So 285 kilometers in 2.5 hours. To break it into a unit rate, that's 1 hour. We would divide both the first and second term by 2.5. Use your calculator. 285 divided by 2.5 is 114 kilometers, and therefore the unit rate is 114 kilometers per hour. And again, we drop the 1 hour because it's per hour. $1.80 for 220 milliliters of coffee. It says please use as your unit rate per 100 milliliters. It actually tells you what your bottom term is going to be. So we're going to put volume on the bottom. Right? It says per, which means that's our second term. $1.80 for your cost for that 200 milliliters. So again, you're going to figure it out as a unit rate. Now you could go for 1 milliliter first, and then you can go 100 milliliters if you wanted to. Or you could just go right to, I'll show both ways. How's that? So what you could have done is you could have done the first method to figure out how much it is per 1 milliliter. So I'll take my calculator. I know I'm going to divide $1.80. Oh, that's not $1.80. $1.80 divided by 220. And the cost per milliliter is less than a penny. It's actually 8/10 of a penny, or 0.00818. It would be tenths, hundred thousandths, 10 thousandths, 100 thousandths, 818 hundred thousandths of a dollar. But per 100 milliliters, we can actually do this by mental math. Just move this decimal 2 place over, and it would be 81.8 cents, or almost 82 cents per 100 milliliters. If I was to do that right to my unit rate from the first without going to 1, I could have divided both the first and second term by 2.2, because 220 divided by 2.2 is 100, and therefore $1.80 divided by 2.2 would give us that answer that we have over here, which is still about 81.8 cents per 100 milliliters, or if you rounded it, 82 cents per 100 milliliters. Question 10 says that Cockapoo gained 32 pounds in 8 years. This is not a random review question. This is actually my dog. My dog weighs about 32 pounds, and he's 8 years old. So do I want to have my ratio set up years per pound or pounds per year? And when you say pounds per year, that makes more sense. So what I'm going to do is I'm going to put my first term, 332 pounds on the top and 8 years on the bottom. And there is no right or wrong answer. I could do years on the top in pounds and figure out how much time it took for him to gain 1 pound. But this is the more practical one. Divide both first and second term by 8, and you can do this without a calculator, because 32 divided by 8 is 4. So 4 pounds in 1 year. So 1 year, and therefore it's 4 pounds per year. Now you could, if we put years, let's just do this for fun. Put 8 years on the top and 32 pounds on the bottom. And what we're going to do is we're going to figure out how long it took him to gain 1 pound. So this is a possible unit rate. This doesn't mean it's not possible. So if I took 8 years and divided it by 32, I would get, so let's just take our calculator here. 8 years divided by 32 equals 0.25 of a year, or a quarter of a year. Therefore, it took a quarter of a year to gain 1 pound. And that is a possible answer. Or you could say a quarter of a year is technically 3 months. So you could say it took 3 months to gain a pound. Or you could say take 365, took 365 days and divided by 4, because that's a quarter. You could say it took 91 days or 91 and a quarter days approximately to gain 1 pound. There's a whole bunch of different ways, but generally speaking, that's probably the one you would use. You'd say it's the dog gained roughly 4 pounds per year. For these questions, it says use unit rate to solve. So for this one, we need to take $12.20, and we'd have to break it down. So 5 Cokes is $2.20 or $12.20. We need to find how much it is for 1 Coke, and then refigure that out for the cost of 6 Cokes. So if 5 Cokes is $12.20, then if I divide by 5, $12.20 divided by 5 would tell me that each Coke is $2.44, so $2.44. And then simply to find 6 Cokes, you'd have to take that value per Coke, multiply it by 6, and you would have the final value. It would therefore cost about $14.64 for 6 Cokes, right? And that's using what we call the unit rate method for determining the missing value in a proportion. In the second one, it says use multiplication or division. So we have, let's just make this bigger here. I'll just take this and make this a little bit bigger. 180 meters in 18.8 seconds equals how many meters in 9.4? The tricky part is 9.4 is exactly half of 18.8. So technically, if you're using the multiplication division, you could simply divide both by 2, and you would therefore know that it's 90 meters in 9.4 seconds, right? That was an easy one. In the 13th one, it asks you the same thing. It asks you to use multiplication or division. So we have 2 minutes and 30 seconds for 240 words, and then it says how many words can you get in 1 minute. So the first thing you probably want to do is think about 240 and just change 2 minutes and 30 seconds. Or actually, we don't even need to change it, because 2 minutes and 30 seconds is the same thing as 2.5 minutes. So in order to get it to, in order to get that unit rate, we just had to divide it by 2.5 and take our words, 240 words, divided by 2.5, and therefore we'd figure out it's 96 words per minute. 96 words per minute. And all we had to do was figure out that this was really 2.5 minutes. Question 14 says use unit rate. So in unit rate, we need to figure out how many hours in 1 day. Hopefully you all know that. So it says 48 hours in 2 days is how much in 1 day? Well, if it's divided by 2, and probably most of you knew it's 24 hours in 1 day. And therefore, to figure out 365 days, multiply by 365. 24 times 365. Oh, 365 means there are 8,760 hours in 1 year. Question 15 asks for the algebraic method. So what that means is, what I'm going to do is I'm going to multiply across my equal sign to create an algebraic equation. So if it's 33 heartbeats in 45.2 seconds would be how many heartbeats in a minute? First thing you need to do is change 1 minute to 60 seconds, because your first one is in seconds. Your second one has to be in seconds as well. So the first thing is multiplying across here. You'd have 45.2x would be your one side of your algebraic equation. Then 33 multiplied by 60. Now, a common mistake is not to change it and keep 1. And that would be the wrong answer, because you can't, because that would be considering it as being 1 second and not 1 minute. So you do 33 times 60. grab your calculator. 33 times 60 is 1,980. And that's all you did. So you just multiplied across here to get 45.2x, multiplied it across here to get 1980, and that's your algebraic equation. Divide both terms, both sides by 45.2. And if you take your calculator again, 1980 divided by that 45.2, oh, that's not right, divided by 45.2 is roughly 43. So x is going to equal roughly 43.8 heartbeats, but it says rounded to the nearest heartbeat. So therefore, we're saying x is going to be 44, and you'll have 44 heartbeats roughly per minute if you had 33 in 45.2 seconds. And your last question for your review says use any method appropriate. So we have 10.2 seconds in 50 meters, which was a speed for like the cars or the guy walking down the street. How far would he be able to go in 1 hour? So again, 1 hour, we have to change that to proper units. If this is in seconds, we have to figure out how many seconds are in an hour. There are 60 seconds in 1 minute, and there are 60 minutes in 1 hour. So it stands to reason that we have to multiply those two numbers together. So 60 seconds in a minute multiplied by the 60 minutes that are in the hour. That means there are 3,600 seconds in 1 hour. So if I use my algebraic equation, just like I did in the last question, I'm going to have 10.2x equals 3,600 times 50, which is 180,000. That's a comma. Divide both sides by 10.2. And 100,000 divided by 10.2 is going to be roughly 9803. So if we retranslate that back again, let's see how that works. If he can go 50 meters in 10.2 seconds, how far could he go in an hour? He can go roughly 9,803 meters. Or if we want to change that to kilometers, roughly approximately 9.8 kilometers in 1 hour.